Welcome to this interesting meeting. Good afternoon. The title of this session, of this very first session, is Experiences for Generating and Realizing Innovation. As Martha has explained, it's not a round table, it's a conversation. The difference is that speakers are expected not to speak more longer than 5 minutes, and will be plenty of time at the end to ask questions to the speakers and to discuss and share impressions with the panel. A couple of ideas about the reasons for this session. One, innovation is a process which is well known not to happen spontaneously. So you need some degree of infrastructure and you need some minimum degree of organization for innovation to occur. And also it's an area where that may take a lot of benefit from different facilitation techniques. So that's what this session is about. We are going to present briefly different types of facilitation techniques which have worked in different environments. But we have to take into account all the time that all of this is strongly environment dependent. So it's always difficult. It's always a hurdles race, but hurdles are not exactly the same depending on the particular country. I try to be politically correct with these cartoons, and I'm not labeled with country names, but I can leave as an exercise for the audience to guess which country this may be and what other country that might be. So, and as a consequence for this, the things are not so easy. So there are no recipes to promote innovation. We have to, unfortunately, we have to put some intelligence into it. And in order to adopt other initiatives, we have to put, as I say, some intelligence into it. So, finally, I like to briefly present the different speakers. This is the order they are going to speak. First of all is Joseph Yazdi, who comes from the Center for Bioengineering, Innovation and Design at the Johns Hopkins University. Afterwards, Brian Pereira, that comes from the MIT Harvard Biomedical Enterprise Program. Then Joel Fink from the Research Laboratory for Electronics at MIT. Frank Douglas from the Austin Center for Biomedical Innovation. Alfred Oh Samson, that comes from the many places. Associate Professor of Health Sciences and Technology and Electrical Engineering and Computer Science from MIT. Myself, and finally Fiona Murray, who's a Professor of Management of Technology at MIT Sloan School for Management. So, no more introduction. Thank you very much, and let's start with the first speaker. Thank you.
Good afternoon. It's an honor to be here. Thank you very much for the invitation. You know, Rahm Emanuel, the President Obama's advisor, said that you never let a good crisis go to waste. So I know your country's in crisis, our country's in crisis. We're all facing a healthcare and a finance crisis. And for those of us who consider ourselves agents of change, let's make good use of this to really shake things up. So just briefly, I'm the head of a center, which is, I have 4 logos on the screen here, not because they're pretty, but because I think it's an important part of the story. We are a unit within the Department of Biomedical Engineering, but we really have equal footing in both the School of Engineering and School of Medicine. And this is a critical element of our success, is that we can bring together clinicians and engineers without any sort of bureaucratic hassles. We also have several other programs that we've launched that I head, the Culture Translational Partnership, which is a way to take our projects to the next level, and also an exciting project, cooperation with USAID on global health innovation. I won't have time to go into all of those because our host has said 5 minutes, so I'll try to rush through it, and we can go into them in the Q&A, and I hope you'd be willing to ask about those. Our mission is really about 2 things, and believe it or not, I came from a corporate environment where the first thing you do is have a mission and vision statement, and the faculty said, what the heck is this? And first of all, that's what they said. Second of all, they said, we're about education. You have on here 2 things on your slide, education and development of innovation. We're not about that. And previous presidents of Hopkins have said explicitly, you're either on this side of the street, or you're on that side of the street, or you're in the middle of the street and you're going to get run over. So you either have to be an academic person or a commercial person, but not in the middle. But our mission really is both. And I think this is an integral part of this, that we believe that students learn best when they're working on real-world projects with real impact. And when we put on here education development, the development comes from working with real clinicians and experts with real big egos, and that's part of the challenge that makes them really into leaders. And the metric of our success is not publications, it's not tenure, it's really about the impact that our students and our innovations have on healthcare. So we're not about bench to bedside, we're about bedside to bench to bedside. Everything we do starts and goes repeatedly back to the bedside to make sure that it stays relevant to solving a problem. And we're not about tech transfer. These are two of my least favorite phrases. So if you're from the tech transfer office at the university, I apologize. But we're really about partnerships. We bring in the partners early on. Those of us who are electrical engineers by training know that when things fail, it's usually in the interconnection between components. And when you go from early R&D to advanced R&D to product development to marketing, at each stage, or from university to companies, something important is lost. It's usually the passion and the vision for where can this innovation have an impact. And I think that's why we try to bring the partners in very early on in the process. And we have a wide range of partners representing all the critical stakeholders needed for success in this, from law firms to government agencies to global health agency, organizations, NGOs, etc. Big companies, small companies, and we'll have time to discuss that later. We go through a careful filtering process when we're picking a project. We think one of the unsung heroes of innovation is picking the right thing to work on, the right aspect of the problem to solve. So our students go through hundreds of potential project ideas, and they end up with one per team. And once the project is selected, a team is formed, a core design team, and the team includes the clinician and the scientific faculty on the team. This is really important. If I see a patent coming out of one of our groups that does not have the surgeon on the patent, that means there's a failure. They did not engage that clinician in the innovative process sufficiently so that he can contribute. So I consider that to be an essential part of the program, and we sign MOUs when we launch these things so everyone knows that they're making a commitment and they own this team, both the clinicians and the rest of the design team. And then we surround the team with a wide range of advisors to really ensure their success. And these are some examples of the successes. I won't have time to go through all of them, but we were only 3 years old, so hopefully when we get to year 7, we'll have a slide like Stanford Biodesign, which will have all the millions and millions of dollars in follow-on funding. All of these have received some degree of funding, but they're very early stage. And these are some more from the last year that the class had just graduated. They're all actually working towards with bridge funding from us, from our culture program, and others from the state to get to the next level. And we also have a whole dimension that we launched last year, which is our Global Health Innovation Program, which is focused on making high-performance, low-cost medical devices. And we debated whether we should have a separate team working on global health, a separate group of students working on low-cost, high-performance innovation, and a separate group of students working on regular, developed world innovation. And we decided to have them mixed. And the reason is that we want the perspective of making a high-performance, low-cost medical device included that kind of thinking into their development of developed world projects. We feel like in order for our students to be successful in the future in industry and for our innovations to be successful, they really have to incorporate the best of both worlds, the developed world thinking and the emerging market thinking. So we have a pipeline that I'm almost done. We have a pipeline of about, I would say, 20 projects every year across the board, undergraduate, graduates, global health, and culture projects that really, I think, has a solid potential to spin out multiple successful ventures each year when we get to steady state. A couple of just feel-good slides. I studied engineering because my father said, Yusuf, be an engineer because engineers are a bridge between human knowledge and human need. But unfortunately, when I came to academia, I realized that if you go to academic engineering departments, they build beautiful piers that allow you to overlook and observe nature and have a wonderful perspective on nature, but it's not a bridge. It's not going to get you over from Niagara over to Canada. It's just going to, it's good, but it's a beautiful view. And this is the problem. And the more successful institution you have, it's even a bigger problem because they say, why change? That's why you want to make sure you exploit the fact that if you're in a crisis mode and people know that the present model is not sustainable, that you start to really try to shake things up. So I think what really drives us is the whole notion of having a real impact on humanity, and that drives students and all of our partners to have a passion for what we do, and that's what's really needed for creativity. Creativity is something, part of human nature, that only really emerges when you really have a passion for what you're doing. And that drives innovation, and that drives back to real impact. So thank you very much.
Good afternoon, and another welcome to Madrid. Some of what I'm going to share with you are along the lines of what Yosef's been doing at Johns Hopkins, and it just tells you that great ideas are not the prerogative of any one center, but great ideas emerge in many places at the same time. But I'd like to spend a few minutes thinking about traditional concepts of education and see what are the gaps. If you look at traditional educational paradigms, the researchers and innovators are in one place. The process and conversion folks are in another place, and the commercialization folks are in a third place. And there's very often very little interconnection between these three groups of peoples. And the challenge of these silos is the cross-linkages, and the sharing of information is often left by the wayside. I often teach at Tufts among students in the graduate programs, and it's amazing to think about the fact that folks who finish their PhD, folks who finish their MD, that's their medical degree, and sometimes many advanced degrees, don't know the fundamentals of existing in life, not their professional life, even on their personal life. Other than a checkbook, their knowledge of accounting and finance is zero. And when you tell them that there is a thing called accounting and finance, which are separate from each other, and then accounting has three different types of financial statements, they look at you as though you have three heads. And then you've got to go through the process. And the same issue is something that we have had to grapple with. You know, MIT, which is the institution that I have had most relationship with, is unusual. It's one of those rare places where folks who teach innovation and folks who teach the translation of innovation into useful products and services that fill the unmet need, interact with each other on a regular basis, is remarkable. And it's no surprise that the amount of innovation that has been converted into products that have made human life better, MIT very easily moves to the top of such institutions. So 7 years ago, Martha Gray approached me and when I was and asked me to join the board of the HST program. And soon she said that, you know, we have a program called the Biomedical Enterprise Program, which requires a board and which has great students which require mentoring. So just to give you an understanding of what this Biomedical Enterprise Program is, the Biomedical Enterprise Program was a very unusual construct. Students did their 2-year MBA, largely at Sloan, but sometimes at Harvard Business School. And they did a 1-year rotation through the biology departments of Harvard Medical School and the clinical departments of Harvard Medical School, and took a innovative series of lectures or courses called Dynamics, wherein they were taught what are the processes that are required to convert your great ideas into medically appropriate services or products, which means they were taught regulatory issues, they were taught clinical development issues, and so on and so forth. So for the first time, students who were doing their MBAs and wanted to be entrepreneurs had an opportunity to go to the emergency room and say, this is where things are not working well. I have a solution. Or go to the operating room and say, well, you know, this is where we could improve a process with innovation. And some folks called it an MD Light, but that's not quite what it was. It was medical education for MBAs who wanted to pursue a career in the life sciences. Now, what we really needed to fix out there was, In traditional MBA programs, students need summer internships, and when they're finished, they need a job. So whose responsibility is that? There is a placement office. So that placement office is the gatekeeper of interaction of these very bright students with the community who's going to employ them or make use of their innovation. So we tried things a little differently. We said that why don't we from day one surround these students with world-class mentors? So we constructed a board which started off with about 10, 15, and then 20 people. And who are the members of this board? The members of this board were folks who were successful at innovation. They were CEOs of public companies, CEOs of private companies, or the C-suite of private and public companies, chief medical officers, chief commercial officers, and so on. So these are the people who are responsible for making organizations run in both the private and public space. The next is we needed people who manage the path of raising money and the people who provide report cards to say, hey, is this a place where more needs to be invested? So we had venture capitalists, we had private equity managers, we had investment bankers, and we had equity research analysts. And the third group is the group who facilitate the interchange, or not quite the middlemen, but the people who are important for the smooth flow of innovation into commercialization. That's lawyers, intellectual property consultants, and people who understand regulatory and clinical development pathways. Now, with this we suddenly had a very eclectic group of people and extraordinary students. And so what we did was, for our quarterly board meetings, we held it at each of our corporate offices so that MIT and Harvard did not have to spend money on these board meetings. And at the end of our board meetings, we invited all the students of the program to come and have cocktails and sometimes dinner with the board members. And this happened 4 times a year, year after year. And this built a long-standing, lifelong relationship between mentors and mentees. And I'll finish in a minute. And what we did was, at the start of the MBA program, we gave all of the students the list of the board and their CVs, and the students picked as to who is going to be their mentor, at least for these 3 years, and hopefully for a long time. And as a result, many of them picked people who helped them then build companies, and you know, the years will tell how successful this initiative has been. So I'll wind up here. I'll just summarize. The fact is that the old saying that good mentors pick students is probably not right. Really smart students pick great mentors and use them in a constructive way to advance their mission, and that's how we get great products and services that fill unmet needs. Thank you.
Well, thank you very much. Thank you, Martha, for inviting me, and thank you all for putting together this wonderful program. In the next few minutes, I'll give you my perspective. My name is, again, Fink, and I'm the director of the Research Lab of Electronics. The ROE, as it's known at MIT, is MIT's largest lab. It also is MIT's first interdisciplinary lab. Was started in one very big crisis, which was called World War II, to develop radar. And in fact, by the end of the war, employed about 4,000 people and was the largest radar production installation in the world. And right after the war, MIT looked at this whole organization and said, wow, this is a wonderful place. People with, researchers with a lot of different expertise came in to solve an important problem. What else could we do, and how could we direct this energy towards the next set of challenges? And that's when the Research Lab of Electronics was born. The lab today has over 600 researchers divided into 70 research groups and does about $50 million in research volume per year. So that's, and I'm the director. I'm also an entrepreneur, so I started a medical device company about 10 years ago, and that company has today 140 employees and it does about $30 million in business. It produces precision scalpels
for minimally invasive surgery. So allows people to do, or physicians to do surgery inside the body without opening it up. So this is... So what I really wanted to do in the next few minutes is share with you some numbers about MIT's conversion efficiency from ideas to impact. And the way I thought to do that is really to demonstrate to you how this system works and to give you some benchmarks in terms of MIT's numbers. And so this slide really tells the story of going from research, which typically culminates in a publication, to a disclosure in which you take many times this publication and disclose it to our licensing office, to a patent filing, which is really a decision of the licensing office, what number of these disclosures, in fact, are converted to a patent application, to a license, which is what the licensing office then does, is it figures out who to license this technology, and to licensing revenue. And so the big players in this initially are faculty, staff, and students, and to some extent research sponsors. They're the ones that really are involved in the research itself. And then obviously there's a licensing office and the patent office, and finally there's the licensee. So these are the different groups that are involved. Now in the bottom line there actually is some very interesting numbers on our conversion efficiency to give you a sense of how many research dollars convert into patents, convert into applications, convert into licenses. And so for MIT at large, these are average numbers for MIT in a snapshot year, about $6 million of research volume convert to 6 technology disclosures. $1 million about 1 technology disclosure. That's MIT's number. Out of that, about 2 are filed as patents. And then one of those, on average, gets an exclusive license. And then finally, if you look at what the revenue is per that $6 million of research volume, about $60 million a year come into MIT or are generated in terms of revenue. So let me see if I could give you the MIT global numbers here. So again, if you look at this, and I'm comparing here MIT to Stanford just to give you an idea of another top university, MIT does about $600 million a year in research volume. When you look at invention disclosures, we do about 600. And so again, that $1 million in research converts to about 1 tech disclosure. A fraction of that, at least in MIT, about 200 of those disclosures, of 600 disclosures, are converted to patents. And those patents then generate revenue. And what we're showing here is for MIT at large, about $70 million a year come into MIT in terms of IP royalty. Quite separate from that are startups that are generated, and so the impact is obviously much broader than the licensing income. But one way to think about this is MIT, on average, charges about 1% in royalty. And so $70 million in royalty that comes to the university basically translates to about $7 billion in annual product sales stemming from MIT IP in any given year. So if you want to step back and look at this in a global fashion, society is investing in MIT every year $600 million. And in a very narrow sense is extracting $7 billion in terms of product generated. Obviously, there are many tens of thousands of jobs that are generated in the process and many other ways of contributing to economic growth. But this is at least one way of looking at it at the investment and return curves. This is another dimension of the story, which is the number of startups at MIT in every given year. And so on average, we do about 20 startups a year come out of MIT. And obviously, this is only part of the story. There are lots of different ways of measuring the total impact. This is a bit busy slide, but there was an effort and a study that was published by Ed Roberts and his Entrepreneurship Center or Trust Center in 2011, and was called Entrepreneurial Impact. And what they showed there is if you take all of the companies that were generated or started by MIT alumni, you reach an economy that is on the order of $1.7 trillion a year. So a pretty phenomenal number. So I'll end with why does it work, and really pose the question of can it work better. First of all, MIT's goal is to transition technologies, not to make a profit on them. I think that's a very important dimension in MIT's success. If the university thinks about intellectual property as a way to make a profit for the university itself, it already begins to misalign the incentives of the inventors and the society and the university, and people start operating on different side of the alley. Startups are very effective at commercializing university intellectual property. In fact, the TLO, our licensing office perspective is that startups are a lot more effective than large companies in taking breakthrough technologies to the marketplace. Okay, a key success factor is student-faculty involvement, a very simple licensing strategy, low incentive to circumvent the licensing office, and an ecosystem that supports entrepreneurship. So thank you very much.
First, I'd like to thank Martha and her colleagues for inviting me to this incredible conference and very important conference. You've heard from each of the speakers thus far, and you will continue to hear that it all starts with an idea. And that idea has to be practical, be problem-oriented. I represent the Austin Bioinnovation Institute in Akron, where we basically talk about patient-centered innovation and commercialization, namely the problem starts with the patient. We've talked a lot about bedside, to bench to bedside. Because of what we do, we like to think of it in terms of patient problem to prototype, back to the patient to see whether it works, then to product. When I was given not an offer I couldn't refuse, but an opportunity that I could not refuse to come to Akron and to implement this institute, I was very excited because 5 organizations, 3 hospitals, the University of Akron, and the medical school, aided by the Knight Foundation, had gotten together and said that they want to form an institute where they would work together to solve patient problems. They would actually collaborate. And one of the things that I said to them is that what I've learned over many years, it's very important to decide to collaborate, but because you want to collaborate doesn't necessarily mean you know how to do it. So we started the process of developing what we called a collaborative, innovative ecosystem. And we introduced many things, but one of them I'd like to describe in the next 3 to 4 minutes is what we call the Synergy Seminar. You know, a regular seminar follows the following format. We invite an expert who speaks expertly for 40 minutes or so, and then expert questions are posed to that expert, and the expert is expected to give expert answers. That's the traditional seminar. In a Synergy Seminar, what we do is we bring problem owners and solution providers together. And we ask the problem owner to speak for about 30 minutes. But at the end of the presentation, having given the clinical, the scientific issues behind the problem, we would like them to specifically list 3 or 4 vexing problems that are associated with their presentation. Then for the next 45 minutes, we have an open discussion led by a moderator, sometimes enabled by a panel. And during that discussion, we try to come up with novel ideas to solve those problems. Now, in making this work, it's very important that you have an excellent moderator who is open and will stimulate discussion. And that you treat the panel not as an alternative to the traditional mode, but you treat the panel in such a way that they are enablers of this discussion. And I like to think of this as not a no-spin zone, but an all-spin zone, where everybody in the audience can be fanciful and think outside of the box as they come up with solutions. Whenever you start anything, the first time you do it really determines whether to be successful. This was the first synergy seminar that was given by the chairman of orthopedics at Summa Health Systems. And he presented this problem. What do you do when you have, either because of surgery, an accident, infection, there is a loss of bone? And you have to replace that bone in such a way that you give whatever material you use, it gives strength. It also is bioabsorbable, that over time it will disappear. And indeed, it is done in such a way that it allows new bone to form. And as the new bone is formed, it is reabsorbed, and the material is reabsorbed and replaced. And this was the first session. And I will tell you that coming out of that session, the results were a project team was formed. In fact, in many of these synergy seminars, they end up with project teams being formed. And in fact, thus far, two companies have been spun out of these synergy seminars. So this is what I wanted to present to you at the very beginning. How do you foster ideas so that they can move towards innovation? Thank you.
Good afternoon. My name is Alfred Oh Samson. It's wonderful to be in Madrid, as always. I'm operating this pointer. So you will see innovation ecosystems. Here's my title, a very ambitious title, Engineering Meets Medicine. What I set out to do was to give you an observation of something that's happening in my group and in sort of related groups in my sort of local environment of research in Boston. And this busy slides reveals an interesting fact of being an academic at MIT and HST and engineering, which is basically you specialize in affiliations. Right? So I have academic appointments in electrical engineering, computer science, and health systems and technology. I have lab resources at the Martino Center that I will talk about. And of course, I'm a member of Yoel's RLE. This is sort of a side effect of the things that you have to do to be effective in interdisciplinary research. Right? This kind of comes about naturally. So on this map, you will see, many of you know Boston. There's a river, Charles River, that's going through here. On the river is MIT, and down by the docks is a place called the Martino Center for Biomedical Imaging. Now, this is a place where we do our research, and this is run by Professor Bruce Rosen, who's going to be a speaker here tomorrow. He's a very visionary in this field, and he operates a very large and successful center in the space of biomedical imaging. And when people come to me, I want to join the group, I put in one condition, right? So I take for granted everybody's intelligent and capable. They have to be able to find their way from MIT to Charlestown, right? And so it's not enough to be intelligent, you have to be street smart, because Boston traffic is tricky, maybe not as bad as Madrid, but this could be treacherous. But it speaks to the more general point that when you're doing this kind of work, you're a graduate student at MIT, you're going into a world-class facility in Charlestown, and you're operating with people in a different domain. It's postdoc-oriented, there's professional staff, there's physicians and scientists, and expensive equipment, people from Siemens or other companies. It's very much a broader spectrum of problems that they have to deal with in a very open, real-life sense. It's part of the territory. So I'm going to tell the story of three people, stories around these three exceptional people. And it kind of gets to Brian's point. He was making a point about an advisor picking the student or the student picking the advisor. So if you look at what these three people have done, Audrey Fan is a PhD candidate in my group. Dave Bowler is an MD PhD out of HST. And he just finished his medical degree. and is studying residency. And Louis Gagnon is a HST engineering student. What combines them is not, they all come from different sort of academic strands, but what combines them is an interest in a compelling problem, which is to non-invasively image oxygenation metabolism in the brain, in vivo. It's a fundamental problem that remains unsolved with profound consequences when we solve it. So I will touch briefly on sort of each of their contributions. It's a tradition in MRI that you name your technique. So Audrey named her technique PROM. Actually, it's a shoo-in for the actual name of the method, phase-space regional oxygen metabolism. And I won't go into the technical details, but I'll leave you with the kind of the take-home message that the idea here is to use MRI, so magnetic resonance imaging, not as a technique where you kind of get gray level difference in an image to separate tissue types, but to map a quantitative parameter. And in this case, ultimately what we're after is the cerebral metabolic rate of oxygen consumption in the brain. Right? That's the physiological parameter that through clever imaging and modeling we're going after. And she has a proposal to do this, is presented this. She has funneled this into very high resolution imaging at 7 Tesla. That's equipment, new equipment, expensive equipment that we make use of. And she's brought up already on her own collaborations with faculty, in this case, an expert in multiple sclerosis. And just at last month's ISMRAM presented some findings on the utility of this mapping technique to separate staging in MS. Here is kind of a central slide, right? So I'm here, Bruce Rosen is here, and David Boas, a person not in MRI, but in optics, right? He's in optics, but interested in the CMRO2 problem. These are the people that Audrey, sort of through her work, has roped into collaborative effort. And she's further roped in people in PET imaging, Jacob Hooker, many of you know. And she has application people. Here's the Katerina, the MS expert. All of these people, through interaction with one student, have become involved in this project. And to turn the next student, Dave Bowler, he also named his technique. He's going after CMRO2, mapping in this time. Not vessel-based, but per voxel, getting an image where the signal value is CMRO2, right? That's his goal. He jotted down for me his connections. These are the local Boston connections. He has national, international outreach, and he's distributing kind of his method to other users of MR. Louis Gagnon, this is a student of David Boas, right? His expertise is in optical imaging, and again, quantitative mapping of oxygenation parameters. And he has a very wide network of collaborators and users in the Boston community and broader. Between the three of them, I see them as sort of the instigators of what we've just these terms that are calling the oxy group, stands for oxygenation study group, right? And what they do through their enthusiasm, passion, and drive is to get all of these people to interact with them in driving a solution that needs multiple different types of expertise, not just MR, not just optics, not just PET, but all of them, right? And it needs the application domains. And it's very wonderful for me as a participant in this to see this kind of happening as we speak. Next week, there's the fourth session of this oxy group, right? So just giving a very sort of narrow view observation of one project that's inching along on the lines of, I see many of the themes popping up that have been brought up already. Happy to discuss this with you one-on-one or on the panel. Thanks so much.
I'm the only local speaker in this round table, and because of that, I'll try to stress some local peculiarities of our environment in innovation. The reason for my talk is to present the EMS Network, which is the network for technology innovation in hospitals. first of all, just a short glimpse on what technology transfer and innovation is in Spain. You can see here that Spain is responsible for about 3% of the world knowledge. That means that it makes the 9th position in the world ranking in terms of knowledge production. That matches the position in terms of economic volume of Spain, which is also 9th. But it's not the same for the technology transfer and for patents and for exploitation. So there's a significant mismatch that doesn't occur in, let's say, similar countries in Europe. So it's clear we have a problem there. And that's one of the reasons why the EMS network was created. EMS deals with technology transfer from hospitals and moving research and innovation from the hospital to the industry. It's it's easy to draw an arrow in a slide like this, but the whole thing, the real thing, is much more complex. And there's a whole workflow here that involves many different actors that should work in valorization, assessment, prototyping, evaluation, etc. And that's the goal for ITMAS, is to improve this kind of support in order to facilitate the transfer of knowledge from here to there. At this moment, the network is made up of 14 large hospitals all over Spain, and what we expect from the network are two kind of results. Well, the first kind of results is towards the components of the network, and the second kind of results are oriented to the external community. As for the internal results, the most important thing we want to do is to foster what we call the innovation support units in hospitals, whose purpose is to smooth the process of transferring technology into the industry. And for that, we have, first of all, to formalize the workflow and to use normalized procedures, to implement detection tools how to detect that there are innovative ideas wherever in the hospital. And we also there are some activities dealing with teaching, innovation, and entrepreneurship. The second type of results is to detect those technological resources and partners who are outside the hospital. And one problem we have is that at this moment it's difficult from the hospital to know which may be the proper partners outside. So one of the missions of the network is to identify those partners and to help the hospitals in establishing agreements, preferably stable agreements with those partners. Then another objective is to share resources and experiences between hospitals. So we allow every hospital to proceed as they want. So we don't plan to have a unique model for everybody. So hospitals in Basque Country, in Catalonia, in Madrid are following different models, and our intention is to share the experiences and to copy all that works and to avoid all that is not working. And also to produce some synergy among hospitals, and this synergy, as we are seeing, is likely to occur in a local environment. And finally, we have to provide evaluation criteria. This is another interesting topic. Nobody has addressed this issue, but how to evaluate innovation. On the one hand, for us in the hospitals to see or to check whether we are doing well or not, and also for the administration in order to see what we are doing. So this is a very interesting topic. And as for the external results, we are interested first of all in this is a new term I've casted, this meta-coordination. It's something that happens in Spain, that we are very fond of coordinating other people. So. And there are many different institutions and organisms which try to coordinate the few ones who do some innovation. So, but this kind of meta-coordination is what we address from EMS Network. Also, the network cannot be made up of just 14 hospitals. That's completely absurd. So we have to incorporate many new partners of different types. For instance, research groups from universities, small technological centers, small and big companies, consulting companies, etc. So it's important that for the next meeting of the network, instead of 14 partners, we will have about 30. It's our objective. And another important thing we pursue is to prepare sort of a resource map of who's who in innovation in biomedical technology in Spain, but not as a report, but as a live tool that may allow people to enter and exit the system. So, and this may be a very interesting tool for hospitals in order to look for companies to which transfer technology to industry in order to see who's doing what in this country, and also for the administration in order to see what they are administering. Actually, in some cases, it's not so clear. They don't know exactly what they are administering. And finally, we have a very big problem in Spain, which is the regulatory framework. Our regulatory framework is extremely stiff. And one thing the network is addressing is to prepare some reports for the politicians in order to convince them that some things have to be changed in the laws at this moment. I'm not sure how successful we will be in this area, but it's very important. So, as you can see, we are actually facing a big challenge with the network, but I think that it may help a lot for the innovation process in our country. Thank you very much.
All right, so you can see from my enthusiasm wanting to come and speak here a few moments ago that I really am delighted to be here, so thank you very much. Like everybody else on this panel, I have a variety of titles and a variety of roles. The one that's probably the most salient today is actually my role as faculty director of the Trust Center for MIT Entrepreneurship. At the center, we do have a mission and a vision statement, but I must admit I can't quite remember what they say. Basically, what we try to do is really facilitate cross-campus entrepreneurial education. And in particular, it's very important to us that in doing that, we really bring together students from the engineering school, from the schools of science, and from the business school. Because I think traditionally there's been something of distrust and certainly not a common language between those different groups. And so a lot of our educational initiatives focus on that sort of integration of diverse teams. Our education is also a little bit different than you might traditionally find, because it's not just faculty-led. It's not just professors who sit in a room and think we ought to be teaching the following 3 things. It's often student-led, so students come to us and say, we think there's a gap, we want to learn about this. Sometimes it's student-organized. It's also led by practitioners. And so we affiliate a variety of people with tremendous entrepreneurial experience into our center. And the best world is when we're sitting together teaching with them, as opposed to it being one or the other. We are really trying to build entrepreneurial skills. And so we're trying to build skills in the sorts of things that you've been hearing about today, identifying important problems to solve and then moving from idea to impact, from idea to innovation. We think it's very important that, we have a strong belief that there is a learnable activity here, that this is a repeatable process, that you can bring some systematic knowledge to. Obviously, entrepreneurship requires success, it requires luck, but chance favors the prepared mind. And so we think that if we can give students a repeatable process, then we've done well. To speak to the issue of evaluation, how do we know when we've done well? We certainly like to measure and count startup companies, but more important for us is really, if students fail, that they know when to stop, when to push the idea ahead, when to stop, and that the next time they try, they do it much more quickly and efficiently. And so that's really what we're trying to engender in our students. We do this through a large number of mechanisms, courses, programs, and so on. But one in particular that we use are prizes and competitions. Prizes and competitions are actually things that have been used for many, many hundreds of years in my own country, in yours. This is a French example. Governments, regional governments, universities, businesses have used prizes to focus the attention of innovators on problems of national significance. This is Leblanc. The French Academy of Sciences offered a prize for the soda ash process, for an alkali process. Leblanc was the winner. This was an issue of tremendous national importance. Today, we use prizes, the word prize and competition, a little bit interchangeably. Just to be clear what I mean, A prize is basically the award that you give to the best completion of a set of activities. The competition is really the structure of those activities and the criteria that you need to put into place. And really, to do this well, you need to define your objectives. What are you actually trying to accomplish? You need to describe and design the competition accordingly. And you need to be very clear about the kinds of outcomes you're looking for and that you really want to measure. I think that you can at least bucket the world into probably 4 kinds of different sorts of prizes and competitions. If you think along the vertical dimension, they go from sort of entrepreneurship and business-oriented to more narrowly innovation, technologically oriented. They can be very narrow. You're looking for a very specific new innovation. Netflix was looking for a much better algorithm to solve their movie selection problem. Android, Google wanted some very specific popular new applications. Or they can be much broader. Science fairs bring people together to kind of come up with new, broad, innovative solutions. Business plan competitions of the sort that we in particular do a tremendous amount of at MIT and in Massachusetts increasingly are competitions that really are broadly focused on actually sort of generating new business plans and new business ideas and opportunities. Why are competitions so powerful? So traditionally, we haven't used competitions in the last many decades as an incentive mechanism. And there seems to be a strong sense that what makes competitions powerful is the fact that they actually seem to induce extraordinary levels of effort. Any of you who've competed in any sort of sporting event or any other kind of race of some kind know how hard you try, even with limited resources. Even when you're absolutely sure that you are not going to win the marathon, you go out there and train much harder than you would do for your normal everyday activity. Competitions, when well structured, seem to kind of create the opportunity for real diversity. They bring different kinds of people together, and they bring different perspectives to bear. You don't have to define the right solution. You have to define the problem or the focus area. You do focus attention on the things that you think matter, on the kinds of problems that you think are important. And most importantly for us in a university organizing these kinds of things, we think competitions are a really interesting way of shaping an educational opportunity. Now, if you do too much of this, then the students spend all their time sleeping in the traditional classes because competitions are a lot more fun. But when well structured, competitions can be, I think, a very powerful vehicle for really allowing for a sort of a very meaningful educational experience. I'm happy to go into more detail, my own time is up, about how to do this. But I think one of the keys of how to do this well, and we've done this at MIT with our 100K business plan competition, and also with much more sector-specific, the Clean Energy Prize, which is very similar, is to really be clear about the objectives. What do you want to accomplish? To be clear about the design. So how many stages do you want? How do you bring mentors into the activity? How do you judge? How are you really doing that? And finally, to be clear about the kinds of outcomes that would actually make you happy. Right? So we do care that successful companies are built and created, but we care much more about the fact that through this process, students are really educated in these entrepreneurial skills. And in particular, that education happens bringing together technical students with business students. So I'll leave it there, and thank you very much.
Okay, thank you very much, all of you. And now we can open the session for questions from the audience. I'm sure there may be a lot of questions. If you are shy, okay, one here. There's a portable mic there. ¿Podéis acercar el micro? Please identify yourself before making...
Thank you very much. Is this on? Yes. Oh, great. Starting with Fiona, you were the last, but we'll ask you the first question.
You can remember, so.
In the area of competitions, I know you're familiar with Peter Diamandis and the X Prize competition. Mm-hmm. Would you like to comment on that and where you think that might go? And I mean, it's a very broad question, sure. But I know MIT does have an X Prize, mini right. X Prize, and I think the University of Washington and maybe
correct. That's
USC.
Right. So just by way of background for people, there's an organization called the X Prize Foundation, which is a not-for-profit foundation which has been established to basically run a series of very large prizes. These are much bigger, in a way, than the traditional business plan competitions that tend to have as their final prize amount money between about $20,000 and $100,000. These tend to be in the region of $1 million to $10 million. The very first one was focused on sort of space and sending a spaceship up. One of the most recent ones was for an energy-efficient vehicle. We've actually been fortunate enough to do a study of that energy-efficient program. And I think, again, what's very interesting is that what the competition does, in my opinion, it certainly causes people to exert tremendous amounts of effort. And it's levels of effort that I think are probably, to an economist, actually economically irrational and potentially highly inefficient. You know, as an economist, you'd like the people who are most likely to win to be the only ones to participate. I think that the point that's going on here is that you tend to be focusing people's attention. People who are already working in something are coming together for a much more focused kind of activity. And what I think makes those prizes potentially successful is they've been structured as an educational vehicle. So they've been structured in stages, and at each stage, a group of innovators is taught a lot about the problem that they're trying to solve, about the regulatory context. And so I think that that's been important. And the publicity that they bring to bear energizes and excites a large group of people around innovation. And so I think those are some of the positive lessons we can learn. And certainly from surveys we've done of those people, it's very clear that people participate, that the money matters, but is much more about the community, building the ecosystem, the education and the publicity that really gets people getting up in the morning and putting all that attention and effort into the problem.
My name is Baltasar Fernandez. I'm from Computer Science Department at the Complutense University of Madrid. Here, I think in Spain, we have a different problem. It's about, the money came from a very specific sector, and usually it's not that easy to build up these multidisciplinary teams. How do you manage to create these teams from different organizations? Or, in Spain, it's quite unusual. Either you go for health money, either you go for computer science money, or either you go for industrial projects. But it's not that easy to create these interdisciplinary teams.
Who are you addressing your question to?
I don't know.
the whole panel. Okay.
To someone who has a solution.
Okay. Volunteers for that?
There's absolutely no question that if you have a prize or there is a grant out there, that tends to bring people together. One of the things which we did to create the collaborative innovative ecosystem was indeed to give some grants. Now, what was interesting wasn't the amount, and this is where I think there's a bit of an answer to your question. What was actually interesting was that we said the following: we would like to have teams come together that would comprise an expert in polymers and biomaterials working together with a surgeon or a clinician and working on a patient problem. And a fascinating thing that happened, as one of my colleagues in the hospital told the story, there were scientists running through the hospital saying, I have a polymer. Is there somebody who has a problem that could use my polymer? Okay. And so what I'm going to suggest is that that I don't know that it can ever be very successful without having some sort of prize in order to fund the work people are going to do. It's not a price to go into their pocket, but to fund the work they're going to do. If you have that, then having the problem clearly stated and recognizing that somebody has a potential solution that could address the problem is sometimes in itself enough of an advantage and an incentive for people to go out and look for collaborators.
Thank you. Manuel, maybe I'll I'll try and take a stab at this. I think that we've got to look at this as innovative people, and innovative programs and innovative policies. And things can happen both from the top down and bottom up. For example, as Alfred, I think, showed us an opportunity wherein a dynamic student went out and created linkages across institutions in the US and abroad, and was the nucleus. Now, that's one dynamic student. But that's not really scalable. To be scalable, it has to move upstream, both policies and programs. And in many ways, policies and programs come where the money is. The folks who are custodians of dollar or financial resources require a visionary, dynamic individual or set of individuals who then drives that downwards. Now, in the US, to give an example, the start of the CTSI programs, the Clinical and Translational Research Institutes, was created by the NIH to drive interdisciplinary collaborations. Now, I must say that while those required collaborations between academia, both basic scientists and clinical scientists, and industry, to a large extent, the industry participation in CTSI at most recipients of that was based on CEOs writing a letter saying that we're going to participate. Beyond that, the participation was limited. But programs within universities on their own without receiving the CTSI went out and built relationships with industry. And so I think to some extent you need all of the above working at the same time to galvanize this change.
There's another question here.
Carl Koster with MIT. I want to pick up on this point a little bit that Brian was making on the scalability of innovation for impact. There's always a lot of discussion about small and medium-sized enterprises and all of the things that we do to build teams and generate innovation. But to have impact, you have to scale this for society's purposes. I know some of the panelists, Frank has been in large companies. Josef, you've been in large companies. So I wonder if some of the panelists could talk about some of the challenges they see in scaling innovation to have a greater impact on society.
I think that's very dependent on the particular ecosystem of innovation. In our case in Spain, our problem is that big companies, the multinationals, don't have but commercial delegations here. So for us, such a contact with the big ones is not so easy. For us, it's much easier to deal with small, medium enterprises. Probably things are different in your country. So that's one of the many differences we have. I don't know.
So, as I said, I have a dislike for the term tech transfer because I think this is part of the problem. What we try to do is to bring in the scale-up partner early on in the process. So, for example, we're looking for projects for our design teams. We brought one in from BD, another one from GSK. They come to us and say, we have an innovation challenge. I know from experience at J&J, often the most innovative challenges are set aside on the shelf. The most innovative ideas and high-impact ideas are put on the shelf within the company because corporate VPs of R&D have to manage portfolios, and they often manage to make it safer for their career rather than what's going to have the biggest impact on society. So those are the kind of ideas they can bring to us. And I can have a team working on it at 1/10 the cost of an internal development team. And if my team is successful in coming up with something that's useful, we have a scale-up partner ready and willing and interested in taking it forward. And on the global health innovation side, the same thing happened with our partnership with USAID and JPIGO. They are the partners on the ground that can scale up and in terms of distribution across the world and manufacturing. And they provide direction to us as to what's needed in the field. So our innovation teams know that if they do solve a problem, for example, of see and treat for cervical cancer, they have scale-up and distribution partners ready to take that on. The problem is this tech push approach or the idea that we're going to come up with something new, exciting and new in my lab. Like I have a polymer guy running around, and then assume that society is going to want what you produce, and that's a false assumption.
I'd like to add a comment. A couple of things. First of all, Brian, I know what you meant, but I don't agree that this is not scalable. And I think Yusuf addressed one part of it, depending how you look at scale. I spent some time at MIT, and one of the things that fascinated me was that which Afar presented and you commented on, namely the students are the vectors. The students would go around and pull together faculty from different departments, different disciplines, and bring them together to act collaboratively. Now, the student has a prize, which is guiding the student's behavior. The prize is their degree. So they do have a prize. That's driving their behavior. But that is scalable, and I've seen it in scale at MIT. I mean, it happens across MIT. So that is scalable. The second piece to it, picking up from what Yusuf said, is if indeed you now link it with someone who has the skill to distribute, to commercialize, and work on problems that are of importance to them. Students can work on those problems. Student faculty teams can work on those problems. And the last comment I will make is, if indeed we believe the data that has come from the Kauffman Foundation is that in a real sense, economies are built not by the large companies, but by the number of small companies, then think of the power of using students as vectors to create collaborators and collaborations around solving problems that are important to commercial entities, to hospitals, etc., who then have the whereabout to distribute at scale.
Yeah, I'd like to, is this active? Yeah, so one thing that we all come to Spain for is to see world-class soccer. That's right. And I'm kind of listening to this conversation. I'm saying, the U.S., we've always wanted to have as good as soccer as in Spain. And what do we really need to do? Well, we need just to have a competition like the El Clasico. That's right. We just need two great teams to compete. And the fact of the matter is, if you look at that analogy, the reason, for example, soccer has been so great here starts way before the competition. It starts in a very early age where very young people are excited about these role models and really see a future in this case in sport, in other cases in entrepreneurship, and in really making a difference in the world through science and technology. So what I'd look to is say, let's not focus on the end game, but actually look at the supply chain that allows society to get to that end game. And that end game is not only about your own local resources, it's about bringing talent from around the world to the place. So we all know that some of your best teams are not only comprised of Spanish players, but have some very good players from around the world. And creating that environment that gets Spain to be a mecca for people to come to realize their dreams around commercializing science and technology. And so I think, while I very much agree that having a good end game is important, I would definitely emphasize the role of the supply chain. And that supply chain starts with getting very young people excited, and it then goes through having great universities that really attract people from around the world, and then obviously good transfer and translation mechanisms.
A word on this subject. I do think that this whole issue of, I think another way of describing that is role models and culture, and it's about who the heroes are in a community and who people want to be when they grow up is extremely, extremely important. The other distinction I'd make is the distinction between small and medium-sized enterprises on the one hand and innovation-driven enterprises who may start small but who actually begin, even when they're small, with an aspiration to grow. And I think that those are very, very different things. Much of the European economies, and indeed a lot of the American economy, is structured around supporting small businesses. And in fact, they do not provide new job creation. It's the businesses that start small but then that grow very rapidly that I think Kaufman is really talking about in job creation. And that means starting businesses that are driven by innovation, are actually solving new and meaningful problems, do actually have a source of competitive advantage, and actually do follow on all the things that we know about what it takes to build a strong business. That doesn't mean that capital will immediately show up at your door, but it gives you a chance to actually build a business effectively. And so I think we have to make that distinction between small and medium-sized enterprises that stay small and innovation-driven enterprises that start small but always aspire to grow and to be transformational in what they're trying to accomplish.
In the meantime, I can say that it's a little bit disappointing to me as responsible for the EMS Network that it seems that we cannot do anything. There's no hope until the whole education system works in Spain. So it's a joke.
José Vaquero from Universidad Carlos III de Madrid. Hearing all this, I'm starting to believe in the idea that Josep Yacid was saying, that we don't want technology transfer. We want to create what you call innovative partnerships. But I think there is a player in this game that is I'm missing, that is just for the technology transfer, we need at least industrial tissue that is capable to absorb this technology transfer. But for this innovative partnership, we need an industry that is not only capable of absorb, it's also demanding this kind of actions that you are describing. So I don't know how many industry or how many people representing industries here. So I think there is a key player missing in this whole picture.
That's simply true. We have the industry we have. So and our education system has to be improved. Our research has to be improved, not so much. And our industry system has to be improved in terms of making them able to really absorb this and even demand. That's absolutely true. And however, one of the things we can do is that even though there are few industrial companies who are able to do that, if we at least knew who they are, then it would be a part of a solution. So that's one of the objectives of EMS Network, is to try to identify at least a few partners in this area that allow us to start it up. So,
Manuel, you're being unnecessarily pessimistic.
I'm realistic.
You told me this morning about all the wonderful innovation that came out of your lab that has gone to international companies. They don't have to be Spanish companies.
They don't.
They don't have to be here. They just have to have a need, and you have to provide the raw materials. And as your slides show, the raw materials in terms of academic output, in terms of the baseline strength of your scientific establishment is there. You just need to direct it, I think, in a different direction. You know, I learned so much on this trip, and I'm really appreciative that I was invited. I learned a lot on the plane last night, reading the Wall Street Journal. There was a whole article about the Wall Street Journal's All Things Digital conference. And one of the articles was about the changing economics of education. And this is a challenge for us because people pay us to teach them. And they sit in a classroom and they pay $40,000, $50,000 a pop. And that whole model is disappearing. So while you're trying to create a great model like us in the United States in your education system, our education system is facing a challenge just like everyone else from IT and the internet. And that has to do with the idea that students can get the content that we provide in the classroom much more efficiently without falling asleep at their own leisure online. So why would people pay to come to a university like Hopkins to learn? And the reason is, I think, the future is in the kinds of programs that we have. They can get the classroom education at home, but they can't get the teamwork and the excitement of working on innovative, collaborative team at home. They have to come to school for that. And they're talking about here about creating high schools. This is about this interview with the head of the Khan Academy, and he was talking about the model of a flip school. So when I was growing up, you would go to school and the teacher would give a lecture, and then you go home and do your homework. And the opposite is now becoming much more viable, and that is that at home I sit down and watch the lecture at my leisure, and then I go to school to do the homework. because I can work on a team to help solve the problem. So I think, in fact, what we're proposing here, this kind of team-based design team approach, makes education much more exciting, engages students. I think it's a much more viable structure.
Questions? One there.
Welcome to Madrid, and I hope you will have time to enjoy our city and our country. I would like to ask a question. You have mentioned that we need to have more interdisciplinary teams with engineering, medical, and business. But in order to have disruptive innovation, do you think that it will be interesting to add to these teams people from the
in terms of outcomes. And we say, well, it's all in the outcomes. But one of the very interesting stories that emerged in the past few years is that of Intuitive Surgical, so the robotic company that's introducing surgical robots. And for the most part, the clinical efficacy of that tool compared to the traditional ways of doing surgeries hasn't really been established, for the most part. But still, the company is selling has been a huge success. And part of that success, when you talk about to clinicians, is about the user experience and the fact that it's a lot more fun to do surgery. It's a lot easier to do surgery. It's a lot more high tech to do surgery. And so thinking about these dimensions in medical device products of how to make a product more usable and friendly and well designed, I think is wonderful. And so having in these teams contributors from other areas in communications and user interface, I think is a great idea.
Sure. Yusuf, Marth, and I have been involved in an approach to medical device design innovation, which we call value-driven engineering. And the components of value-driven engineering are, of course, quality being the sine qua non, must be high quality, is that you try to optimize from design all the way through to commercialization. You try to simultaneously optimize the utility of the device to the end user, simplify the complexity for the end user, and demonstrate savings to the healthcare system relevant for the use of that device. So this component of the usability and user interface is really very important, and we would think will become even more important. In fact, there's an area which is called human factors, and the FDA actually has guidelines for medical device companies in terms of looking at the impact of their devices when a user employs the device. Not only from a viewpoint of safety, what would happen if they use it badly, but also from a viewpoint of the ease of use, and they actually do have guidelines for that. During this conference, which we just held, one of the winners of a competition we held in value-driven engineering was from a university in Virginia. And what fascinated me was the dean who presented the project pointed out that on the teams of students, they also had students who came from the art school, who were artists, looking at engineering problems, and they actually approached it differently from the scientists would and as the engineers would. And I think it's a model when you think indeed of this user experience with respect to devices. We might very well see more and a greater degree of multidisciplinary teams coming around that.
Yes, a small comment on that. It's not only, I think, that they're financing more basic research or paper-oriented research, but when they're evaluating you as a researcher or a university professor, they're also valuing much more the papers than the patents up to now. Now things are starting to change, but since a few years ago, you were valued for your publications. I mean, a patent was not worth a lot for a position or for getting grants or that, so
Same
people
goes in the US.
didn't care about the patents.
Patents are worth zero in a promotion. That's at MIT. You can't come with a list of patents and say, give
Okay,
me
yeah,
tenure.
so that is solved by having companies who really make use of the patents. But here we don't have the so many companies that really will buy your patents and put them in the market. And on the other side, you don't get promotion or you don't get value for your patents. So why should I patent here? So
one of the differences in the U.S. is absolutely correct. There's no value for the patent. But in the U.S., you have the Bill Gates, you have the Zuckermans, who say, I don't really give anything about having a degree. I've got this idea that I'm going to commercialize. And they go.
Okay.
And so you have this in the U.S., this entrepreneurial type spirit, in which there's a fascinating college actually in Massachusetts called Olin College, that is actually, Olin College. So in the U.S., you can have these types of diversity of approaches and individuals who will take an entrepreneurial approach regardless of what the system says. And, but that's the environment of the U.S.
Okay, unfortunately time's over, but all of you have the opportunity of continuing the discussion after the session. Thank you very much.
I just want to thank this panel for a very terrific discussion that revealed all kinds of challenges. But I think the people in this room, we can take a number of small steps which add up to huge leaps that will try to address all the barriers that have been listed that I think are global barriers. They're not limited to Spain. And MIT has its share as well. And I'd focus on the last point that Frank made and that we made throughout. If we can at least start by attracting and fostering those individuals who, for whatever reason, are so motivated to make things happen. Those exist everywhere in the world. And if we can get them successful, that has to be part of our strategy. And that's what we're going to hopefully continue to talk about here today.